when I look at example 5, the first thing I notice is there's two different variable expressions. And so I immediately know I'm not going to be able to isolate. This is not going to be one of the easier types of problems. Okay? But also, since they're not even the same function, one of them's tangent and one of them's secant, I can tell I'm probably not going to be able to factor either. So remember, from your flow chart, you want to try to isolate if you can. If you can't do that, then you want to try and factor. And if you can't do that, then you're going to have to do something else. This is going to be that something else. It's not the easiest thing to do in the world. Okay? I guess the more of these that you do, the more comfortable you will be with this. But I need a way of relating tangent and secant. And so remember the one that says tangent squared theta plus 1 equals secant squared theta. Remember that identity? That's a lot of times that's a good way to go so you can do some sort of substitution or something. Okay? But what's going to happen in this problem is we're going to square both sides. Okay? In order to get that tangent squared and that secant squared, we're going to square both sides of this. This doesn't happen very often, but every once in a while that's a good thing to do. Okay? So if you knew how to square this in your head, that would be great. You can't just distribute the 2, so make sure you're not distributing the 2. You'd have to do something more like FOIL when you square this. Okay, so FOIL, you're going to get tangent squared x plus square root of 3 tangent x plus another square root of 3 tangent x plus square root of 3 times square root of 3 is 3. And so like terms, we would have tangent squared x plus 2 times the square root of 3 tangent x plus 3. That's what we would have on the left side when we square both sides. Okay, kind of difficult to do that in your head. You definitely don't just distribute the 2. Please don't do that. So when we do the other side, that's just going to equal secant squared x. And so at first glance, it doesn't look like we've really helped ourselves out at all. It looks like we've made this more complicated. However, okay, what we can do, since we know that one identity, tangent squared x plus 1 equals secant squared x, what we can do is a substitution. Since that equals secant squared x, we can plug that in. We'll just do an algebraic substitution there and see what happens, because something nice usually happens. Tangent squared x plus 2 square root of 3 tangent x plus 3 equals tangent squared x plus 1. If you notice, there are like terms. See, you've got the tangent squared x on the left and on the right. If you notice, if you try to get those two like terms together, they're going to cancel each other out. That tangent squared x is going to completely cancel out. And so if you rewrite, you have 2 times the square root of 3 tangent x plus 3 equals 1. Got a new equation. How many variable terms in this equation? Just 1, which is great. That's great news because when I only have one variable, then I can isolate. Okay? If you only have one variable, you'll be able to isolate this. And so let's do exactly that. We're going to subtract 3. That says 2 square root of 3 tangent x equals negative 2. Then what would we do? What are we going to do? Divide. Let's divide. Let's divide by all that junk right there. 2 square root of 3. And so I'm looking at tangent x, and those 2's can cancel, so we've got tangent x equals negative 1 over the square root of 3. And so you can rationalize that if you want to, but I'm not sure that you want to, because look at your chart. Okay? This is from the chart. We've got square root of 3's in the chart, but look at the chart. We know tangent is sine over cosine. And so what you'd be looking for is 1 over square root of 3. If I look at my sine over cosine and look at my 1 over square root of 3, notice in your 30-degree range, those 2's would cancel out. You'd have 1 over square root of 3. I'm looking at a 30-degree reference angle. Okay? Whoops. but we can't really say 30 degrees because we're not in degree mode, we're in radian mode. So I wouldn't say 30, I'd say pi over 6. Okay? That's a pi over 6 reference. So don't say negative. Okay? Don't say negative pi over 6. Say something more like pi over 6 where tangent is negative. Okay? Pi over 6 where tangent is negative. And so you look at where that is. We know tangent is negative in the second and the fourth. And so we do what we always do. This is pi, let's call it 6 pi over 6. That means pi over 6 right before that is what? 5 pi over 6. And then this is 2 pi. Get a common denominator, that's going to be 12 pi over 6. So pi over 6 right before 12 pi over 6 would be 11 pi over 6. Okay. Now, there's one more thing that's kind of important. When we squared both sides, okay, when we squared both sides, we created extra answers that weren't really there, okay? And I'll prove it to you real quick with a simple example. If I said x equals negative 5, okay? X equals negative 5. If you squared both sides, okay, square, you'd have x squared equals positive 25. Agree? If we solve that, we took the square root of both sides to solve that, you're going to get plus or minus 5. Right? There's a positive root and there's a negative root. And so what I've done is I've taken the number negative 5, and by squaring both sides, I created this extra positive 5 that wasn't supposed to be there. Okay? My answer was supposed to be negative 5, but now all of a sudden it looks like it's plus or minus 5. That extra answer is not supposed to be there. That's called extraneous. And you can probably guess why that's called extraneous, because there's this extra answer. And so, what's going to happen? Anytime you square both sides, you're going to have to check your answers for one of those extra ones. Okay? Because that's going to happen a lot of the times. So, how do we check our answers? Well, how have we always checked our answers? We would plug them back into the original problem. So the original problem said tangent x plus square root of 3 equals secant x. So 5 pi over 6. Let's try 5 pi over 6. Okay? Tangent 5 pi over 6 plus the square root of 3 is supposed to equal secant 5 pi over 6. Okay? Question mark, because we don't really know if that's true or not. So you can do this by hand if you want, but since we're just checking our answers, we might as well use our calculators. Put it in radians. So tangent 5 pi over 6. Plus the square root of 3. 1.1547, okay? 1.15470. Okay, so we need to do secant 5 pi over 6. Secant, how do we enter secant? Secant's 1 over cosine, right? So we'd have to do 1 over cosine 5 pi over 6. Is that the same thing? That's not the same thing, is it? Okay? That's not the same thing. So you know what that means? That means that this can't be an answer. That was extraneous. Okay? That 5 pi over 6 looked like an answer, but it's not actually an answer. So let's try the other one. Let's try 11 pi over 6 and see if it works. We would have to do tangent 11 pi over 6 plus square root of 3 should equal secant 11 pi over 6. And so we have tangent 11 pi over 6 plus square root of 3. Oops. Same thing. 1.1547. Okay? So then secant is 1 over cosine. 1 over cosine 11 pi over 6. Hopefully that's the same thing. Hey, it is the same thing. That is the same thing. So you know what that means? That means that 11 pi over 6 is actually a solution. There's only one solution, and that's 11 pi over 6, not 5 pi over 6.